H here the constant. So that inside here we have the expectations of dn and x of n come with this transpose times the vector h and plus the h transpose expectation. So now you put, because these are constant, so you put expectation inside. The only thing random variables is pocket. So that is expectations of xn transpose times h. Are we still with it? Yes.
This matter again, when you multiply bracket
this part with this part. So I multiply that with that, that with that, and that with that, and that with that, and the sum bar.
We don't have nothing to there because you multiply d of x with.
You want to know what this cost to? Yes, so the thing is, this is what it is. This is a number. This is simply a number, right? I have a row vector multiplied with column vector. So this is just simply a number. And what you ask here is maybe have this term and another term which is transpose. So a number and transpose are the same, so that's why I can put them together number 2. Does that answer the question? Okay, very good. So at least someone wants to follow up here. Alright, so I have this now, and remember our goal. Our goal is to find the edge to minimize that term. Why find the edge to minimize that term? So now we assume now, so we have this, so the edge here. And edge is ever right now. But now we assume that we know this term. Let's say we assume we know this term. Right? And then we only have to optimize edge to minimize the whole thing. So to make the thing simple, we assume that we know this thing, the P vector, which is equal to the expectation. So I can easily put the expectation. If I don't have it, I put the T outside. So there is expectations of D of n times the xn. Right? Then I divide that. This thing here is simply what is this vector? So the xn is this guy. Xn is this. The xn vector is just xn minus 1 and so on. So when I take this, multiply with this, I got another vector. And I take the expectation. So that would give me the expectation of dn and xn. So that is really the gamma of the cross correlation of d with x. Cross correlation of d with x. And that is a location. What other location? What is that? I put it side up. 0, right? Because n and n. Right? So we only look at the difference between these two. So that would be 0, and then the gamma of dx of 1, and the gamma of dx of n minus 1. Alright, so we let that. We assume the two things are right. And now, this whole thing here, I let it be a matrix. So now I have this thing here. R is equal to expectations of xn t here. And the same thing now. So what I do here is I take this xn and multiply here is the row vector over here. Right? So this is n by 1 times 1 by n vector. What do I have? N by n matrix. Right? An n by n matrix where x entry is xn times something, xn something else. Right? So that matrix now, and that is this thing here. So for example, what is the first entry going to be? the autocorrelation of x is of 0. Right? How about another one? Also the autocorrelation of x is here 0. All that I know about. Right? How about this here? Autocorrelation of x is of 1. Okay, so the messy matrix we have, but I hope you see the pattern. So I have this, and here the gamma of x is 1 here, or maybe minus 1. Okay, because I take this thing here, maybe xn. Oh, okay, it doesn't matter, it's a 1, right? Because I do everything real now for simplicity. Okay, so I want 0 here, and the finds I have here is gamma of x is n minus 1. So that is autocorrelation function of x, and is n minus 1 previous sample. Okay, so I can construct the whole matrix. Alright, so it's 2 with me. Okay, so by defining that, and assume that I know this number, if I know this thing, then I know P and I know R. Okay, I know P and I know R. So, in that the case, and now I can put them together. So my mean square error. So let me call this something. Call this some E here, for example. Let me call this F. So call this function some function F, and it is depend on H. Right? So now F is a function I need to minimize, and it's only depend on what the filter I use. The function depends on the filter, and I can write now the more compact form. And it is equal to, this guy here, just really the autocorrelation D with itself at 0. So that is just gamma of D at 0. So that's constant minus 2 times V transpose H. So I'm going to draw out the vector now. So, okay, and you know that it's a vector. Plus A transpose RH. Okay. This is a multivariate function, right? Because H here is not just number but a vector, many variables. I have to design a filter with several coefficients. But you see, it recognizes simple form, right? It's quadratic form. So I can take the gradient of this. I can take the gradient. So if you learn any course on multivariate variable, we can take the gradient of this, of F and H. What is going to be? It will be a minus 2p plus maybe 2 times RH. Okay? You can take the derivative of that. Are you familiar with that? Okay, let's show. For example, single variable is p times H, and here it's like, a squared times with a constant times this. So when you take the derivative of single, it's just 2 times p, and this thing here is 2 times, AH, for example. In a vector, then it is form. Yes?
But we give column matrix and to our matrix with a round matrix.
What is R? R is the matrix.